Okay, guys, so remember my data is going to be a little bit different from yours because I only put 4 points in there, okay? So all my results will be very different from your results, but it doesn't matter, it's the techniques I'm going to show you, okay? So hopefully you've got this nice, beautiful picture. Up here, you can just obviously click on the different tabs to see what else is up there. Okay, and I've got quite a few tabs because I did this with another class as well, okay? So my first tab up here, 1.1, has my original data. T and Y, I called that. 1.2 is my graph for T and Y. 1.3 is the data I fed in with you guys, I think, 1912. And tab 1.4 is this. Now, notice the difference between the two graphs. Different points are kind of giving different predictions. Is your graph the same as my graph? It goes up to like 2080, 2120, something like that. Mine goes all the way up to 2240, but then again, look at my y-axis, it goes down to 7.4 seconds. So depending on the way you've scaled your graph, they will look quite different, okay? So, here's what I'm going to do. I'm actually videoing this, I think, and I'll post the video on the OLP, so you can then track back and see what I'm doing. When you were on this page, you went to Menu, Analyze, Regression. And regression was the magic word for fit the best model on. And I'm going to go back to linear regression. And if I click on it, it should give me the equation. So if I click, oh, I've got quadratic here. And I've got, what was this model again? Do you remember what it's called? Exponential. This is like a percentage change model, which is a little bit more complicated. But my linear hasn't appeared, so let's try that. Menu, Analyze, Regression, Show Linear. Okay, the linear's appeared, I just didn't click it correctly. Now, I'm guessing that many of you may have then written this down. And if we want to find out when the y value hits 9 seconds, you substitute 9 seconds here and you solve this simple linear equation. Many of you may have done that, okay? But I want to actually get the computer to do it for me. So it'd be really good if I could draw on maybe this line here. I think about the equation of this line, you should quickly be able to understand that this is y equals 9. Everywhere on this line, the y value is equal to 9. Horizontal line on a graph, y equals 9. Okay? So wouldn't it be great if I could find that intersection point and then read off the year? That'd be great, wouldn't it? Okay? Well, let's try it on this menu and see if we can do it. So under the menu button here, you can analyze, and you can actually plot a function. So the plot function here is asking you to type in the equation of the function. Now, this is just function notation for y equals. So f1 of x, y equals. So let's type y equals 9, which is great. Now, it would be good if we could see where those two lines intersect. And so if you go Menu, Analyze, unfortunately, on this menu, can you see there is nowhere where I see intersection? Just doesn't exist, does it?
I think it's the trace one.
Well, let's go to graph trace is the only option there. There's nothing that says intersection, is there? Which would be really good because that would get straight to the intersection. But there's a graph trace right at the bottom. So let's go to graph trace and let's just move with our arrows here. And you've got an idea, haven't you, of roughly where it might be. But the accuracy isn't quite there, is it? Because you're kind of just looking where it might intersect. And it jumps on each time by about 8 years, 6 years, something like that. So we can get a rough idea with graph trace from this menu. But we do have a different option. So this is the extra tricks that I'm going to show you. If you go back to your spreadsheet of data, if you click in a blank box, we're actually going to do the linear equation on this page, which will be a bit weird because we won't see it, but we'll just get the numbers for it. So let's watch again. Menu, statistics, statistical calculations. Oh, that looks like a familiar menu, doesn't it? So statistics, statistical calculations, linear regression, mx plus b. What was the x data? I think it was year, wasn't it? And the y list was time. And here's the extra bit here. Save regression equation 2, F2. I'm going to change that to F1. It looks quite complicated, but let's see what happens. Okay. Now down this side, it gives you the equation of linear regression. And if you think about it, it's just the same equation as before. For me anyway. 28.6 was the plus b, negative 0.0094 was the slope or rate of change. Fantastic. So you're thinking, well, so what? What is the use of that? Well, here's where the magic happens. Go to Document, Insert a Graph. Okay. Now, when we insert a graph page, the computer's expected to type in 3x plus 2 or 7x minus 6 or that last linear equation so we can see it. But where did we store it to? We gave it a name and it was called F1. So as soon as I've gone to this particular graph, this menu bar opens up. If you press up, F1 of x is already in there. This is the linear equation that models that 100 meters data. So I'm just going to, it's already in there, and I'm going to tick it here. So it plots it. And if I press return, it's plotted it. Why can I not see it? I've plotted it, negative 0.009 plus 28.6. Why is it not there on the axes?
Oh, it's on the right.
It's way over there. It's on the right. This is year 0. We want year 1912, 1950, 1980. And look at the y-axis. This is negative 6 to 6 for the seconds. So we need to go and change the axes. Menu. Where do you think we can change the axes? Window zoom. Okay, so window zoom. I'm going to go to window settings because then you get the overview. Here I'm going to put 1910 up to, what, 2150, something like that. And the Y minimum, I think we'll start with 8 seconds and we'll go up to maybe 11 seconds. Ah, there it is. So we've recreated our point plots and the line, but we've taken away all the points now. But now we've got it on this menu, we're going to try the same thing. 9 seconds, intersection, and read off accurately. So let's just see if that will work on this menu. Menu, graph entry, function, f2 of x equals 9, y equals 9. Okay. Menu, analyze the graph. Ah, can you see it? Intersection. So we're in a kind of a different page. This is plotting functions. There's a lot more powerful on this page to actually play with intersections and lots of other things there. So if we go to intersection, and it's clever because if we'd have plotted curves, there may be multiple intersection points. Can you imagine that if there's a curve like this, maybe multiple intersection points? So it asks you to zoom in on the intersection point you require. So I've got a little dashed line, and the bottom left it says lower bound. From where to where do you want me to search for the intersection? So all you have to do is just click a point, just move the dotted line before and after. and it grabs it for you here. One final thing. This looks a little bit weird. 2.08 E3, 9. What's the 9? It's y. It's an x, y set of coordinate points. Okay. So this must be the x value, which is the year. What year is this? 2.08 E3. 208 years after, maybe.
Isn't E something about like multiplied by 10 or something like that?
So this is the calculator way of saying the following. E3 we interpret as times 10 to the exponent 3. This is one of the failings of the calculator. I think just the pixels on the calculator is not able to fit that in, but it can do this. Okay? So this is 2.08 times 10 to the exponent 3. So it's 2.08 times 10, 100, 1,000. 1,000. So that's 2,080. That's something, isn't it? Okay. So that's just an extra trick. Be interesting to know if can we actually get this as the normal year? Maybe it was 2083. What do you think the biggest year that this might have been? It's 2.08 E3. We've said that's 2080. What's the greatest and what's the least year it could have been? What do you think? Tell the person next to you. We've got 2080, but what's the lowest and what's the biggest year it could have been? 30 seconds with the person next to you.